All right, RASPCT. Let's do 2.8, inequalities and absolute values. Let's go ahead and do two variable inequalities. That's basically having two variables, an x and a y, in your inequality. We're used to equations with two variables, an x and a y and an equal sign, but now we're going to elevate our learning to do inequalities. All right, if you look at the equation or the inequality, y is greater than or equal to 5 over 3x minus 1. The first thing you do is you want to graph the line. Let's for a second pretend that's an equal sign. Y equals 5/3 x minus 1. In order to graph it, you would start at the y-intercept at -1, and then the slope is up 5 over 3. So if you go up 5 and over 3, that's where you would end. And that's what our line would look like, extending in both directions. Now we have to address the inequality part, the greater than or equal to symbol. How do we figure out what that does to the graph? Well, what it does is you have to shade either the top part of your graph or the bottom part of your graph. And how do we decide that? We're going to need a test point. You're going to test a point. Basically, any point that is not on the line will be a good test point. But usually 0, 0 is the easiest one, just because zeros are easy to work with. And 0, 0 in this case is not on that red line. All right, we're going to test that point, 0, 0, to see if it's true or not true. By true or not true, I mean plug it into the original inequality. Plug in 0 for the y, plug in 0 for the x, and this is what happens. 0 is greater than or equal to -1. Now you have to ask yourself, is that statement true or not true? Is 0 greater than or equal to -1? Yes, 0 is always going to be greater than -1. So if it is true, and if 0, 0 is true, then you're going to shade across it. And actually, you're going to shade across the entire side. That's my shading, by the way. Hopefully your shading will be a little bit neater. All right, but that's what it means. If the statement is true, shade over your testing point. If the statement is false, don't shade over your testing point and shade on the other side. Let's try another one. Ooh, we have a system. There's two of them on one. All right, let's do both. Let's go ahead and look at the first one. We have 3x minus 2y is less than 10. Now, if you notice, that's in standard form. So a lot of you guys, we talked about this the other day. A lot of you guys were taught in Algebra 1 to change it to slope-intercept form. That is perfectly fine, but you don't have to. You can do what's called the cover-up method. So basically, you would cover up the y and solve for the x. When you do that, if you divide both sides by 3, you get x. Well, if we think about it as an equal sign, x is equal to 3.3. Oh, I did the y first. Just kidding. There it is, 3.3. Now let's do the y-intercept. If I cover up the x now, and then solve for y, you have y is equal to -5, and it already showed up here. So there's our graph. Notice it is a dotted line this time. Can you figure out why? It's because this is not less than or equal to, it's just less than. So when that's the case, we have a dotted line. So there's our dotted line. Now we have to test Do I shade above that dotted line or below that dotted line? Again, I'm using the test point 0, 0. Ugh. If I test 0, 0 by plugging it into that first equation, I get 0 is less than 10. That is true. Since 0 is always going to be less than 10, I'm going to shade across, there's my testing point, 0, 0. I'm going to shade on that side. All of it. All right, let's do my other equation. The x is greater than or equal to 5. Now, when you have an equation or an inequality that is x equals or x something, then it's always going to be a vertical line straight up and down. This is going to be a solid line because it's greater than or equal to at 5. So there's my 5, and there's my solid line that goes straight up and down. Now we're going to test if we have to shade on the left of the green line or the right of the green line, because we got to shade one side. We can still use the same testing point 0, 0. If I plug 0, 0 into the x is greater than or equal to 5, I do get x is greater than or equal to, 0 is greater than or equal to 5. And then you have to ask yourself, is that true? And it turns out that 0 is never greater than or equal to 5. And so don't shade on this side, shade on this side. Now, since this is a system, you have to look at both shadings. All right, where do both shades overlap each other? And it turns out that they overlap right in here. And so when you're doing your homework, you're welcome to shade the red and shade the green, but the main thing I need you to shade in super, super dark is where they overlap, which is right there. Okay? That's important for systems. Let's go ahead and do some absolute value inequalities. Now, we learned the other day how to graph these. Remember, absolute values look like V's. They kind of look like this and look like this with slope of 1. But then we move it around. We know that this -4 moves our vertex 4 units to the right, and this +2 moves it up 2. So our vertex is actually right here. There it is. But it is also an inequality, so we also need to shade. But do we shade in the inside of the V, or do we shade on the outside of the V? It's the same process. Choose a testing point. Again, I'm choosing 0, 0 just because it's the easiest. There it is, 0, 0. Again, the only time you cannot choose 0, 0 is if your graph goes through 0, 0. So in this case, the graph is nowhere near 0, 0, so you can test it. Go ahead and plug in 0, 0 into that inequality. You're going to get 0 is less than or equal to 6. All right, and then you have to ask yourself, is that true or not true? And it turns out, yes, 0 is always going to be less than or equal to 6. So if it is true, then you shade over the truth, which now means all of this is the truth. All the way. Even over my face and on this side. All right, so outside of the V, nothing on the inside of the V. Okay? Let's go backwards. What if they give you a graph that is already shaded? You have to come up with the inequality. Okay, that's not too difficult. It's a little bit tricky. Notice they give you 2 points. You should be able to write an equation of a line that goes through 2 points using the slope and all that stuff. But if you look, you actually can just count. You can count the slope and you can count the y-intercept. Here's the y-intercept. And the slope looks like it's up 2 over 1, up 2 over 1. So we get the slope and we get the y-intercept. The slope is 2 over 1, and then the y-intercept is 2. So that's our equation. If I wanted to just have an equation of the line, that would be it. But notice there's this blue shade. So now we have to turn it into an inequality. All right, so we have to decide which symbol do we use, greater than or equal to, less than or equal to. But we do the same thing. We want to test a point. Again, I'm testing point 0, 0. But in this case, notice I want 0, 0 to be false because the blue part is not on 0, 0. It's on the other side of 0, 0. So I want the equation to be false. So when I plug in 0, 0 into the x and the y, I get 0 is something 2. And I want that to be false. What symbol would make this statement false? If 0 is greater than or equal to 2. That is a false statement, and that's what we wanted. And that's the inequality we're going to use. Y is greater than or equal to 2x plus 2. All right, and that's our final answer. All right, here's our last example for the day. Here we have an absolute value equation or inequality because there's shading. Notice my shading isn't great. It's that yellow blob right in the middle. And it's supposed to extend all the way up. But it's shaded basically inside the V. All right, so how do we write an equation of an absolute of a V? It's using an absolute value. The first thing we need to realize is that here's this original. I move the vertex to the left 2 and then down 7. All right, so we're going to the left 2 and then down 7. And then the slope of the legs, it looks like you're going, if we look closely, starting here, up 1 over 2, up 1 over 2, up 1 over 2. So the slope looks like it's up 1 over 2. So there it is. The slope is up 1 over 2. We're moving 2 units to the left and then 7 units down. That's our equation if we were just needing the red graph. But now we have to accommodate for the shading. Let's test 0, 0 again. But this time we want it to be true. The reason why we want it to be true is because all of this is shaded, including the 0, 0. So since the 0, 0, our test point, is part of the shade, we want our inequality to be true. By plugging in 0, 0, I have 0 is blank negative 6. Blank negative 6. What symbol makes this true? It turns out that 0 is greater than or equal to negative 6. That will be true, so we're going to use that inequality to write our answer. Y is greater than or equal to 1/2 times the absolute value of x plus 2 minus 7. All right, go ahead and try the homework and see how it goes.